as 1 out of 2 voting block. This block is developed in as a block type in PCS7 environment, and we use the safety library from Siemens S7-F FH systems. So we use the description here to implement the 1 out of 2 block. We in this scenario, in this block, we have two quality signals that they are F boolean. They are F boolean, failsafe boolean, F real, two F real as input. So we need to use the output of drivers, failsafe drivers, to report the quality of signal and the actual uh, mm, value after being converted from raw data in the input channel. So they are converted. The raw data is converted based on the engineering range, high and low. Possibly it's level, possibly pressure, or any other safety parameters that we generated. So we need two drivers to quality signals. Quality signals are reported from QBAD, and value are reported from the V output of the safety system. So the other parameters are a delta 5% for deviation monitoring, and delay time is 5 seconds. For feedback, there's some limitation. There are some limitation for block processing in F block types. So we need the connection from output to input. Let me just change the color. So we need to just report the output into the feedback. We have a failsafe value and acknowledgement in order to acknowledge when the shutdown happened, and the source of shutdown is getting normal, and if we want to reset and acknowledge the alarm and make the reading back to normal. So these are the main parameters. Let us focus on the this chart, how we implement it. So the quality signals are okay. So QBAT 1 and QBAT 2, they are false. No bad reading or bad problem in transmitter. There's no problem in transmitters. The difference between input 1 and input 2, the input 2, the absolute value of these, the absolute value of their difference is within the delta variable. So this is the ideal case. Uh, the quality normal is NR is the overall status of the signal is getting true. It means the overall signal processing is okay, normal 1 is okay, normal 2 is okay, and which value is reported from input 1 and input 2, the value that is closer to the previous output will be reported as the output of the block. As an example, input 1 can be 25.3, input 2 can be 26. If delta is 5, we are within the range, no deviation happen, and we will have a happy the block is happy and nothing wrong will be reported. But what happened if we have a deviation? Consider input 1 is 20, but input 2 is getting 26, and deviation, um, the delta is 5, and you can see that deviation is getting 6. So difference is more than delta, but we are within the time delay. Time delay, consider the time delay is 5 seconds, and within these 5 seconds we just behave as before when everything is normal. So during the time delay, uh, input 1 or input 2, which one is closer to the previous output, we report that as the output. All the qualities are getting okay. But if deviation is mm, more, if it happens for a longer period of time, more than 5 seconds, so we will report a fail-safe value, and that will be a shutdown. All the normal signals, they are false, and it's a shutdown. Everything is not normal, and that will be a shutdown. So this is the first case. Qualities are okay, but for the next cases, consider one of the quality signals, like QBAD1 is getting true, and it's a meaning of not okay. QBAD, um, if it's getting true, there is a channel failure or something like that. So we need to report if input 1 is the channel for input 1, it has a failure, we need to report input 2 with the good quality signal. Overall, status of block is true. It means that it's still um, it's okay, the block is okay, with one reading, but normal one is reported to be false. There's a problem with normal one, and we should go and check. The maintenance team should go and check the check what's happened to the faulty transmitter. And if both inputs are we report the bad quality, it's a it's a shutdown, and the fail-safe value will be reported as output, and this will be a shutdown, and uh, all the quality or normal signals will be false, and we need to check what happened into what happened to the transmitters. So we have some charts here. Let me check the first chart here. Input 1 is more than input 2 here, and input 2 is reported as output. You can see here the difference the difference between these two variables. The difference is within the range. That's too much delta, within the valid range, within the permitted range. So it's okay. The difference is controlled, and the difference is within the permitted range. Okay, it's okay, and we can see that input 2, the circles are the previous output, and we can see that from here input 2 is increasing and input 1 is decreasing, and here we will report input 1 as the uh, output of the block. So that's the first ideal case. No deviation, everything is okay. We just should check that which input was closer to the previous to the previous to the previous output, and that can be done very easily in the programming. We programmed the block with the S7-F FH uh, uh, FH systems. Then that was very uh, easy, can be done easily. So the next chart is explaining the quality signal. So here we are within the range, but the Q bad is important. Consider input 1 is reported to the output, but there is a quality issue with input 1, and we use input 2 as output, and then we had a quality issue with input 2, and we will report the failsafe. This is the failsafe value. We report the failsafe value as the output, and that will be a shutdown. So when we report the failsafe, there's possibility of a shutdown. And the last curve is um, regarding to uh, the range deviation between input 1 and input 2. So let us just see what's happening. Input 2 is decreasing gradually, and from this point here, uh, from here, the the deviation is getting more than delta, but as you can see, these intervals are the cyclic cycle of CPU, and we just uh, take action in the next cycle of CPU. So in here we detect the deviation, and we wait for the delay time during this period. From here we report the input 1, and normal quality of everything is reported to be okay. The block is working perfectly normal, but uh, the deviation is getting worse, and the block decide to report a shutdown because the deviation is not returning to is not returning to the line below mm, the delta, the area here. So when deviation is getting more than this area, as our example here, when the deviation is more than this area, and if it's stay in that area for a long period of time, like delta, more than delta, that will be a shutdown. The shutdown will be reported, and we need to press acknowledge to reset the shutdown. The